So let's move on to preparing for the build. Preparing the host system. So the host system is this Gen 2 live GUI, live USB that I've booted. That'll be the environment we use to build Linux from scratch. So initially the tools on this live GUI will be used to build the temporary tools within Linux from scratch, and then the temporary tools within that will be used to build the final system. So the host system requirements, it shows you all the packages that the host system must support and the minimum versions of those packages. So you cannot perform a build of Linux from scratch successfully without these packages and without these packages at these minimum version numbers. So the versions have got to be the same as or greater than the version numbers here. It does say sometimes, like this one here, is that the version greater than a certain number, a certain version level, are not recommended, has not been tested. I've found over the years that tends to be the version of the bin utils that you're about to install in Linux from scratch. So it makes sense if a version that hasn't been released yet obviously hasn't been tested, so it's a little caveat saying that if you come along in 6 months' time and you're using a distribution, a host Linux that's got an up-to-date version of binutil, say 2.45, that it hasn't been tested. There might be something about that version, or even 2.5 or 3.0, for example, that significantly changed the way binutils works, and therefore it would affect the build and potentially make the build fail. So that's worth bearing in mind as well. And what they do now is they've got this script here which does the checking automatically for us and produces a nice output. So if we copy that, just highlight it and then paste it into the terminal and press enter, you can see it runs away, it gets all the versions from all the packages. It checks the symlinks, which is what this mentions here. Some distributions use dash or mork, dash instead of bash or mork instead of awk, the GNU awk, and they've not been tested and they're not supported by the Linux from Scratch project. So it checks here that you've actually got those symlinks pointing at a GNU version of awk, yak is pointing to Bison, and the shell is pointing to bash. So if you haven't got those installed, you'll need to install them. I do have some videos, they're a little bit old now, but they should still stand. I do have some videos, 10 videos for what were the 10 most popular distributions according to DistroWatch at the time, that show those particular distributions, which packages need to be installed. So if I go to playlist, it's probably the easiest way to search for it, and it's this one here. So if I do view full playlist, host configuration for Linux from Scratch chapter 2.2 host system requirements. So there's one there for Debian, it's Buster, but it would still work for what are we on now, Bullseye. Bullseye, I can't remember the other versions now. That should still work. Elementary OS, Endeavour OS, Fedora, KDE, and so on. So some of these need a little bit of work, some need work that's similar to others. So for example, Debian and Ubuntu are fairly similar, as I remember, and others such as Endeavour OS and obviously Gen 2 don't need any work done at all. But I do show that the script is working and that the versions work for the Linux from Scratch that was around at the time, which I don't know which version it was. It was probably in 2020 by the looks of it, so it's 5 years ago nearly. Yeah, it's probably around version 9 or 10 as a guess. So yeah, that could be useful if you're using a different host system. As I said before, I thoroughly recommend using Gen 2. Failing that, Endeavour OS. It just save you a little bit of grief. But if you've got no choice for some reason, then yeah, hopefully these can give you a hint in the right direction. So everything's okay. There's an okay there. I can't remember what it says here. Probably error or fail or something. It'll say in this column next to the version that's not appropriate. All the symlinks are correct. It's done a C++ compile and it works, and it's reported that we've got 4 logical cores available to use, so that's beneficial to know. So let's move on. Again, it goes over what chapters are for. So these are run on the host system and run as the root. Chapters 5 to 6 are run as the LFS user on the host system. And then chapters 7 to 10, we run as the root user, but we're in the root system. So it's a good thing to be aware about what user you are, because we do change a little bit, as I say, from root to LFS to root user. And it's important that you are the right user to make sure that the build is smooth. So that all that detail is there. Right, so this is creating a new partition, and it's create a partition for LFS to be stored on, a swap partition, and a grub BIOS partition, which you'll need if you're booting with the BIOS, but you've got the GPT format partition table. And as it says, it's typically one megabyte. So because I try to keep these videos as simple as possible, so there's less chance of error when building Linux from scratch, I don't tend to use UEFI, I don't tend to use systemd, and I don't tend to use GPT partitioning, just to make the build similar all around. It makes the build a little bit quicker. And especially if you're a first-time LFS user, you don't want to be confused by other things where you've got options and things. So I'll just try to keep it as simple as possible. And obviously, if you found LFS interesting and you want to go back and do it again, then maybe that's something you could do, is create it on a GPT partition with UEFI and systemd, etc. But as I say, that involves more work. Each one of those 3 things involves a little bit more work. Convenience partitions. I generally always create a boot partition. It says it's highly recommended here. My reason for using a boot partition is that it segregates the critical boot files, so that's the kernel basically, and the grub files that are used to actually start the machine. It segregates them from the main system, so, and also set it up so it's not normally mounted. So it means that day-to-day use, if you did a command that deleted something and it accidentally deleted the boot, because boot's not mounted, it wouldn't actually delete it. Or if, for example, you got some sort of virus or something happened to your system, because boot's not mounted, it's basically hidden, there's less chance of it being corrupted or affected by any outside influence. So that's why I always tend to create a separate boot partition. With the other ones, especially with these demonstrations I do on the videos, it's probably not a lot of point in creating separate partitions. Again, it just adds to the complexity. The complexity involved in creating a separate boot partition, I think, is warranted for the protection it gives. And it's minimal extra work anyway. And as it says, any separate partition you want automatically mounted must be specified in the etcfs tab file, so we'll see that at the end when we've completed the compiling. So creating a file system on a partition, it says here about using ext2, 3 or 4. Well, ext4 is the current one. It's been around for probably 10 years or more. there's no point in using the older versions. Even with the boot partition, I use ext4 because it's journaled. It gives that extra protection, if you like. And it says there's a few other bonuses, nanosecond timestamps, if that matters. Very large files, that won't matter because kernel files are small in comparison. It says that other systems, file systems, are used for specialized purposes, but the ext4 is the general Linux format, so that's the one I advise to use. So there's no detailed information about how to lay out the partitions in the Linux from Scratch book. There never has been, and I guess that's because it's down to you how you want to lay it out. So I'll go through that. It just gives hints as to how to create the file systems on the partitions. But as we saw on the previous page, that there's no specific information. It just gives them information to give you the choice of how you want to do it. So I'm just going to show you how I'll be preparing it for this video and how I tend to generally prepare the disk. Now, one thing is, because I was having problems with this machine yesterday, I was doing some testing, and on the hard disk I haven't now got the Windows system that I've just come from. It's got Linux partitions, so that's wrong. It's not what you would see. If you'd come from a Windows partition, you would see 3 or 4 Microsoft type partitions there, so bear that in mind if you're scratching your head wondering why I've got Linux partitions. That's why. As I say, overnight I've been running tests in this machine, and it seems to have been okay overnight, so I'm hoping that it's going to behave today. And as I say, I thought it was something I did initially, but I don't think so now. So that's a bit of an anomaly, unfortunately, but it is what it is. So what we've got to do is to get rid of those partitions. Now, we could go into fdisk and just delete them one by one. We've got the potential problem. It doesn't normally cause a problem, but we've got a boot sector, or you would have a boot sector on there that's Microsoft boot sector, and if you let the machine boot after you've deleted or recreated the partitions, it would try and boot and then it would just lock up. So ideally we'd want to delete these partitions and start with a fresh disk. Now, one way of doing that is to use wipe FS, which wipes file system, well, it actually wipes partitions from the disk. And because we want to erase all of the disk, I want to use the A option to erase all, and initially I want to use the N option, which is the no action. So it does everything except for the write, and as you can see, it needs a device. So what I do here to be sure I'm dealing with the correct device is to list it with -L. That's the correct device. It looks right. Check maybe what the model is, and then what I do is to double click that to copy it to the clipboard and then paste it in, so there's no potential problems that could be caused by typos. So for example, if I actually typed say SDN, which the N's next to the, sorry, SDD, for example, the D's near the A key on the English keyboard, and I might have a SDD drive, so I might be wiping the partitions off the wrong drive. So by double clicking and pasting, it helps ensure that you are dealing with the right device. So if I do this, it comes back, I think on the Windows one it comes back with 3 or 4 lines, but in this case it's come back with 2 lines. It's written or erased the signature, and then it's come back saying success. Well, it hasn't actually done it because I told it to do everything except for the write. So you can see I keep on repeating it, and it's still coming back with the same information because it hasn't actually done anything. And if I do fdisk -L, you can see everything's still there. So what I'll do now is to remove that N switch, which is the bit that tells it not to do the write, and this time it will do the write. It's come back with the same message, but now if I do fdisk-l, you can see those partitions have gone. And also if I do wipe FS again, it doesn't do anything because there's nothing there for it to do. Now, as I say, we've erased the signatures for the partitions, but the boot information is still there. And also if I go into fdisk to edit this and create a new partition, it warns me that it's found the signature for a partition there. So all it's done is marked this as these partitions as being erased, but that's all it has done. It's marked a flag saying they're erased. It hasn't actually erased anything. The information's still there. So in theory, I could reconstruct these just by typing all this information back in. Whether or not that's possible, I don't know, but it could be in theory. So another way to ensure that the disk is completely erased is to, well, for a mechanical disk, there's two ways. You can either write zeros to it using DD, or a better way is to use the built-in security erase command that's on most modern, well, all modern disks, I'd say probably within the last 10 years, 10, 15 years or so. And to do that, we need HD Palm. And there's a security help option here. Which tells us options which we can apply to the disk to do various security functions with it. Now, I'll give you one warning now. You have to be very careful what you do here, because you could potentially lock yourself out of your disk and not have access to it. So be very, very careful if you do decide to do this. Now, a disk could be frozen where you can't make any changes to it, and it also can be locked where it's locked for access to the security commands. So by default they're unlocked, and there's various security levels which can be used to access these commands. Now by default you don't need to select the master or user. If it's an ordinary drive that hasn't been had any settings changed before, you don't need to normally bother with that. One thing that you may come across a problem is the BIOS of the machine you're using might automatically freeze the disk to prevent any changes made to it, which is kind of a security thing anyway. And you can find that out. It's to see if it's frozen by doing HD Palm -I and the device you're dealing with. So we're dealing with the device SDA. And at the bottom you can see that security is supported, but it's not enabled, it's not locked, it's not frozen, and there's no expiry. I think that's for the number of attempts for the password. So in theory we should be okay to get this drive erased without any further effort. On Dell machines in particular, and I believe some other manufacturers, but I know for a fact Dell have always been like this, the BIOS does lock the drive, or sorry, not lock it, it does freeze the drive. So if you were on a Dell and you did this command, there wouldn't be the word "not" there, it would just say frozen, in which case what you need to do is to, when you've done the command and you've got the error, so if I do the actual command to start this off, which is to set the password, so HD Palm security set pass. So I always use the password in capitals because that's what's there, and it just means that, in fact I should double click and paste that. It does mean that if I get interrupted or something happens, I'll get called away. It does mean if I come back and think to myself, oh crikey, what did I make the password? Well, it's there in front of me on the help screen. It's not a password as in for security or to stop eyes prying into your data. It's a password to lock the drive, and only the person with the password can unlock the drive to allow the drive to be used again. So that's all it's for. So we're on dev SDA. Again, really I should copy and paste that in. And you can see that has issued, that's worked. If you come back with an error saying, I think it's mentioned something about sense data, what you need to do is to go to the start button here, the menu button, and click on sleep. Allow the machine to go into sleep mode and then wake it up by pressing the power on button or pressing a keyboard button or wiggling the mouse. And what you'll find is that the machine then becomes, or the disk then becomes unfrozen, and that command should work then. So now we've got this drive locked with the password. We need to erase it, and generally this security erase is enough. If you're concerned about information being left as an enhanced drive, which usually takes a little bit longer. With SSDs, both these commands tend to take about the same amount of time. With mechanical drives, they tend to take a little bit longer. The enhanced tends to take a little bit longer than the erase. And in any case, the SSD is normally quite quick. It might be a matter of seconds. It might be 10, 20, 30 seconds. Whereas obviously mechanical drive, it's got to visit every sector. It could be a matter of hours, and it might be 2 hours, 3 hours, 4 hours, it might be 8 hours even, or longer, depending on the size of the disk. So that's something to bear in mind. So the next thing to do to actually perform the security erase is to, I normally recall this command because all you need to do is to change the switch to the command security erase. You've got to supply the password to show that you know you're the one dealing with this, so you want to deal with the disk as you locked it with that password, and press enter. And that's now erasing the disk. So this is one that looks like it takes tens of seconds rather than a couple of seconds. So just wait for that to finish. And just out of information, there is disk activity light on if your machine's got disk activity light, and it's gone off, and yes, it's finished. So that did take about 10-15 seconds, and that now means that I've got a completely erased disk. So if I do fdisk-l /dev/sda, you can see it's still erased. And in fact, if I do od/dev/sda, put that through less, just look at the sectors that are on the disk. What's happened there? Oh, right, yeah, I don't need to do less. In fact, I can just do that. You can see that there's a line of zeros. The star means that those zeros are repeated, and it'll only update the screen if it finds anything different. So you can see that that drive is now completely wiped of anything that was there before. I've just thought of another way that you can wipe the drive is you could use dd infile equals dev0 outfile equals /dev/sda. For block size, well, it's either going to be 5112 for an older hard disk, or 4096 or 4K for a modern disk. I think SSDs tend to be either 4K or 8K blocks minimum, so I'm going to make this 64K blocks and say erase the first 10,000 blocks, for example. In fact, probably the first 1,000 blocks would be enough. And all that does, that erases the first few sectors, and although the rest of the disk won't be erased, the initial boot sector, partition table, and any further details beyond that will all be erased. So if I run that, obviously with a SSD such as this is gonna, oops, it's hard to type and talk at the same time. This is obviously going to wear out the disk a little bit, but you can see I've erased the first 64 megabytes of that disk by writing zeros to it. So that's an alternative way, not preferable for an SSD really, but certainly valid for a mechanical disk. So, right, yeah, we've now got a completely blank disk. let's start creating the partitions. So fdisk/dev/sda. It's created a new, well, yeah, because it's completely wiped. It says device does not contain a recognized partition label, and it's created a new DOS or MBR type disk label. That's fine. And if I do P for print, you can see there's that signature it's created there. It's put it there. So the first thing I'm going to do is to create a new partition. I'll create a primary partition, accept the default first one, accept the default first sector 2048, and I'm going to make this 256 megabytes because this is going to be my boot partition. And that's created there. So if I do P to print, you can see there's the first partition I've created. The next partition, create new, primary again. The next available one is partition number 2, so I'll take that, start the next available sector, and I'm going to make this 1 gigabyte for the swap. Now, it used to be the case that the recommendation was 2 to 2.5 times the amount of memory for a swap drive, or swap partition rather. That's probably a bit pointless these days, especially with multi-gigabytes of memory. For example, if this machine's got 12 gigabytes of memory, that means I'd create a 24, maybe even a 30 gigabyte, 32 gigabyte swap partition, which is just ridiculous really, because all that happens, especially on this SSD, if I was to use that, is that it's going to wear the SSD down even sooner. I think these days a swap partition is something to be used as a warning that you need more memory for your application, or on multi-core processors to reduce the number of cores in use. So even 1 gig's probably over the top, but it's sufficient if something needed to complete and it needed that amount, then it's there. It's a reasonable compromise, I think. With Linux from scratch, I believe, I'm not completely sure now, but certainly recently GCC is the package that's probably used the most memory per core. I'd say up to 2 gigabytes. Whether it's grown big enough that it might be just over 2 gigabytes now, I'm not sure. I've not looked into that, but I would say that especially as I'm creating a swap partition of 1 gigabyte, that 2 gigabytes per core would be a good estimate. So this machine's got 4 cores, that would be 8 gigabytes of free memory, so you'd probably need 9 gigabytes arguably on the machine minimum. This machine's got 12 gigs, so arguably that 12 gigs should be enough without even having to touch the swap partition. The kernel does occasionally use a swap partition, but just maybe a few kilobytes or a few megabytes. I don't know what the reason is for that, but it does occasionally use a little bit. So that's the swap partition I've just created, but it's got a type of Linux, so we need to change that. So if we do T for the type, allow us to change the type of the partition. It's come up with default of 2, so I'll just accept that by pressing enter. If you don't know what the partition type is, what number it should be, you can type L to list them all, and it lists all the available types. And recently the fdisk now prints up a list of the most commonly used ones. It never used to do this, so rather than hunting through and being a bit unsure, for example, there's several Windows 95 ones there, it just lists up the most common ones here for you. And as you can see, the swap partition is 82, so that's what we type in, and it even tells us that it's changed it to Linux swap / Solaris. So if I now do P for print, you can see we've got a Linux partition, which is our boot, and a swap partition, which is partition number 2. So finally, I'm going to create the root partition. So this is the main partition where the rest of the system will be stored. Primary again, select the next free partition, select the first available selector, and this time I'm just going to press enter for the last sector to use the rest of the disk. And you can see it's created a partition filling up the rest of the disk. This is a 250 gigabyte disk. It's used the remainder. So that's my partition layout now. Do W to write and exit. That's written. I can double check that straight from the command line with fdisk-l/def/sda, and there it all is. So now I can use the commands in the book to format these file systems. So the first one is to format using the ext4 file system, and as I said, I'm going to create that file system on the boot partition. So that's SDA1, and that's done. That's quick because it's only 256 megabytes. I'll recall that command and just change that to 3 because that's the root partition. So it'll take a little bit longer. And that's done. And then lastly, we want to create the swap partition, or the file system. It's not actually a file system, it's more like a signature to show that it's a swap partition. So this one is SDA2, and that's done. So nothing will have changed on fdisk, but we've now got file systems sitting on those partitions. Setting the LFS variable and the UMask. So throughout the book, the environment variable LFS will be used several times. You should ensure this variable is always defined throughout the book, throughout the build process. It should be set to the name of the directory where you'll be building your LFS system. We'll use MNT LFS as an example. And as it says, you can choose any directory you want, but for consistency, it's probably best to stick to MNT LFS. It just shows that you can build this anywhere you like. It doesn't have to be on this location. If you're building LFS on a separate partition, this directory will be mount point for the partition. So that is what we're going to be doing. Choose a directory location and set the variable for the following command. So as you can see, MNT LFS is in italics, so that's indicating that you can change that to whatever you want, but we'll just take that as a default. And it explains there, having the variable set means that the contents of that variable will be substituted whenever we use it. So make the -v LFS $FS tools means that LFS will be substituted for MNT LFS /MNT /LFS tools. Now something new is they're setting the UMask. I don't think this was in 12.2 as I remember. It might have been, but I can't remember. Despite that, it's still quite new. And it explains there, this is in case the default UMask for the host system's not set to 022, and the reason why you do want it to be set to that. And it says here, always check that the LFS variable and the UMask are set at various points. It'll be worth checking that. Just to make sure they're set, because it could affect the way Linux from scratch is built. It does suggest editing the bash profile there to store these changes, but on a live CD or a live USB, there's probably marginal benefit to that. We're not going to be logging out of the root, so it wouldn't be refreshed there. The Linux from scratch user are going to be creating, I think these are put in its bash profile or bash RC, I can't remember which one. So we're going to be getting instructions doing that anyway. So like I say, it's a bit pointless, I think. If you're not using a live environment, that you're actually using a real live system, then it might be worth doing if you're going to be spreading this over several days, for example, or several sessions where you have to log out. But I'll be doing this all in one session, so I'm not going to do that. So mounting the new partition. So let's start by making our mount point. So this is a location for the partition to be stored. So you can see it's created the directory MNT LFS because that's the contents of that variable. Now we're going to mount the root partition at LFS because that place now exists. So SDA3 was our root partition, and you can see it's done that. So if I do df-h, you can see we've got the biggest partition, which was 233 gigabytes, is mounted at MNT LFS, which is what that variable is set to. If you're using multiple partitions for LFS, mount them like this. So yes, I've got a separate boot partition. So what I'm going to do is to make the boot partition, now that we've got the root partition mounted, so that this partition, this directory I'm creating here, will become part of the root partition. So that's done, and now I can mount the boot partition as well, and that's done. Now I don't think we write anything to that boot partition until the end, but it's there in case we do write something to it. Next thing it says is to change the ownership of that directory to root. And 755 permissions in case the host distro has been configured to use a different default for MKFS. Okay, so I don't know what that means by different default. Maybe the different settings when the file system is created. So the different permissions, for example, maybe that's what that means. Ensure the new partition is not mounted with permissions that are too restrictive. Run the mount command without any parameters to see what the options are set for the mounted partition. If no SUID or no dev are set, then the partition must be remounted. So let's have a look at that. And no, all we've got is RW and rel A time, so that's fine. We don't need to do anything else. If you're using swap partition, ensure it's enabled the swap on command. So let's run that, and our swap partition was dev SDA2, and you can see swap on has mounted that, and it's confirmed that it is mounted. You can see anytime swap on will display that. So now the new LFS partition is open for business. It's time to download the packages.